database connectivity. In this lesson, we're looking at the Java Database Connectivity JDBC API structure. What is it doing? How do we use it to manage database connections, execute SQL statements, process query results, manage transactions, but also because JDBC is designed to work with different databases, it's designed to work with whatever database really. So when you're connecting to a certain database, how do you know what it is and what it's capable of? For that, you need to be able to discover database metadata, interpret that, and also to be able to dynamically discover information about the structure of the query results, so you can dynamically sort of adapt to the way you're processing queries. Right, well, let's take a look. So we start with a general sort of overview of the place and role of Java database connectivity. JDBC API provides us with an interface to interact with databases. On one side of the connection, JDBC driver will manage the connectivity with the database using native database protocol, whatever it is. It depends on which database you're connecting to. On the other side, the JDBC driver gives you a standard interface through which you interact with the driver. That standard interface is described by a Java SQL package. The Java SQL package contains lists of interfaces that describe how you work with whatever database. Driver is a set of classes that basically implements these interfaces. And you would have a driver per database type. So you get an Oracle driver, you got a Derby driver, you got DB2 driver, you got MS SQL driver, whatever, depending on which database you want to connect to. So the job of the driver is to basically provide database-specific native protocol implementation. But you won't really need to know that because your code will be written against the interfaces written part of the Java SQL package. You code to the interface type, and then that interface, implemented by the driver, will be physically provisioning you the connectivity with these or the other database type. Yeah, the driver will handle that for you. So to be able to select which particular driver you'd like to use, you need to make sure the driver first, the actual jar files, archives that contain the driver, are in your class path or module path if you use a modular deployment. And then you place the driver archives into the modular class path, and then within the program, you select which driver you would like to use by using JDBC URL. Okay, so the JDBC URL starts with a protocol, which is JDBC, then the type of driver. For example, provider of that driver is Oracle, or provider of the driver is Derby. It's just another database. Yeah. So which particular provider you're using. Some providers give us variants of drivers. For example, Derby doesn't really do that, but Oracle does. Oracle has several different variants of how exactly would you like to connect to the database. And most commonly used variant is called thin, thin driver. Anyway, and then there is the identity of where the database is, what's it called, which host, which port it's on. That part, the connection details part, may vary because it depends upon which provider, which driver you're using, what is that database, it depends, yeah? But that's generally the syntax of the JDBC URL. You're selecting which provider you're using, you're selecting the driver, and you're telling it where is your database, basically. Where do you want it to connect to? Okay. Course notes here contain information about an older style of loading JDBC driver. In earlier versions of Java, there was a slightly different mechanism, but you can find it in notes. Now, your application logic can then interact with the JDBC API and eventually get down to the level of the database through that JDBC API. However, there's another layer of code which we actually don't discuss in this course at all. And that layer of code is called JPA, Java Persistence API. Now, that is an automation on top of JDBC, basically. So JPA allows you to map Java objects to your database tables and interact with your Java objects. And then the JPA API will translate these into the actual JDBC underlying statements. So you would not be writing the JDBC low-level code. You will be interacting with JPA objects, just normal Java objects, basically. And then these interactions will be translated into the actual actions against your database. So you'll be able to query data, save data, but you won't need to actually write low-level JDBC code because JPA can shield you from that. Well, that is covered in another course, Development Applications for the Java E7 platform, if you're interested in that, in the JPA. And it's a great automation. But on this particular course, we are looking at sort of the basics. Yeah, we're just looking at what if we don't use JPA, then, how do we deal with JDBC directly, right? I suppose it may also give us some insight as to what JPA does for us, right? If you understand the JDBC API, then in the future, you probably better understand exactly the type of automations JPA performs for you. Okay, well, what is the structure of JDBC API? So this is the stuff you'll find in Java SQL package, right? There is a class called Driver Manager. And from that class, you can actually obtain your database connection. From the connection, you can obtain statements. You can create and prepare statements. There are three types of statements you could define. There's a basic SQL statement, there's prepared SQL statement, and there's a callable statement. It is recommended to use prepared and callable statements. It's highly not advisable to use basic statements. So prepared and callable are much more advisable. Callable statements are used to invoke stored procedures functions. Prepared statements pretty much for everything else, right? If a statement that you're executing, statement, prepared statement, whatever, if a statement that you're executing happens to be a select statement, a query, then it returns you a result set, which is a representation of a set of records that is a result of your query. So you can process the result set, you can step through the records and do things about the results of the query. All of these objects implement auto-closable interface. So actually you can use a try with parameters block because it will create implicit finally. If you don't, if you create your own finally block, you really, really have to close this. Also, it's important to understand that the closure order is absolutely important. If you are closing these objects, you must manually, if you write in your own final block and you manually close in that, so you call in, result set close, statement close, connection close, yeah? Okay, if you do that, you must close result set first, statement second, and connection third. You mustn't do it the other way around. Why? Because you won't get any errors. If you just close the connection, from the Java point of view, everything will be fine. You close the connection, fine. Okay. But the database never received a notification to close cursors and flush the cache. So the database will have dangling resources. The fact that you close the connection in a Java program doesn't mean that your database performed appropriate cleanup. Closing a result set and closing a statement isn't just something that you do locally in your machine. You actually signal into the database as well. Yeah, so the counterpart, the server side, will also release resources. So if you forget to do it in appropriate order, then you will really annoy your database administrator because you will be eating into the database resources without closing them properly. Although seemingly within your Java program, everything may look just fine, yeah? But in your database tier, it won't be. So please make sure you're actually closing them in the reverse order. So if you open connection first, you prepare statements, you execute a query, then you first close the result set, then close the statement, then you close the connection, right? That is very important. And then finally, all of these different actions may throw you SQL exceptions, which just one of many Java exception types. It's a checked exception, you're supposed to catch it. or explicitly throw it to the caller, but eventually, I guess, catch it somewhere. In addition to your normal Java exception handling stuff, like, error message and these sort of things, you also have additional couple of methods that are called get SQL state and get error code, which indicate the SQL state and error code of the database. So that translates the database error information into the Java world. Okay, so that's your API structure. Now let's take a look at how to actually do these steps, right? So we start with obtaining the connection. You prepare JDBC URL, and here are a couple of examples. URL that goes towards a Derby database, URL that goes towards Oracle database, right? Derby is a very basic Java database that can be embedded inside a Java program. It's really kind of minimalistic. It's really, really basic. Anyway, if you're using pre-JDBC4 driver, there's an extra step, and it's in notes how to actually load the driver first. But if you're using post-JDBC4 drivers, which in this course we certainly are, then you just do that URL, and that's that. You don't need any extra steps. You may identify your user and password with the database, and then you use driver manager class get connection method, and you pass these, URL, username, password, and you connect to the database. That initializes and obtains a connection for you. Okay, so there you go. Connection object is initialized. Now what? Now we use that connection object to actually execute some statements. So you've got different types of statements. As I say, there's this basic statement, there's prepared, and there's callable statement. And it's generally recommended you use prepared and callable statements. But before we get there, before we get to prepared and callable statements, let's just take a quick look at the basic statement first, right? So connection, create statement. All right, that gets you basic statement. Then you describe what you want the statement to do. And it could be a query, insert, update, delete, whatever. Just any SQL, whatever you like. It's a string, just text really, yeah? And notice, it's important, notice that you actually concatenate in parameter values right into the string. Okay. Then you decide how would you like to execute that statement. You can execute the statement using the method execute query. That returns you results.object, which represents the records returned by the query. If the statement is not a select statement, but anything else, and it doesn't matter what it is, update, delete, whatever, doesn't matter, insert, for all other actions except select, you use method execute update. Okay, and that returns you the integer number of rows affected by the statement, right? How many actual records were affected. If you want to, you may use a generic method called execute, which returns you Boolean, true if that statement happened to be a query, false if it happened to be anything else but the query. Insert, update, delete, create, alter, drop, whatever. Okay, so if it is a query, you get result set, and then you decide to process that. And if it's not a query, you can get the update counter, how many records are affected by the statement. So that was the basic statement. However, you highly recommend it to use prepared statement instead. Notice the crucial difference. Prepared statement is not concatenating parameters. Prepared statement is using parameters as substitution parameters. So you have these question marks where the parameter positions are. You prepare the statement beforehand, connection prepare statement, and you specify what these statements should be. And then before you execute the statement, you supply parameters. There are two styles in which you can do it. There's one style which is set object, parameter position, variable you want to put into that parameter, what value do you want to put in, and the parameter type. Notice that parameter positions are indexed from 1, not from 0. I know. Everywhere else in Java, the 0-based indexes are used, but in JDBC API, 1-based indexes are used. That's That's just life. Okay, that's historical reasons, whatever. First parameter, first question mark is actually position 1 rather than position 0. So slightly odd, I know. Alternatively, instead of set object method, which allows you to qualify the value and the type, you could use this set and then the type method, in which case you qualify, well, position, then value. You don't need to qualify the type because the type is essentially qualified by which method you are using, right? Set big decimal, set int, set string, set date, whatever you need. So these are the alternative approaches, really. And then you can execute your statement, execute query, or execute update, or use generic execute, just as we discussed on the previous page. There's not much difference here at all. Okay, now what about callable statement? Well, that is what you do if you want to invoke stored procedures or functions, right? So you describe the way you want to call whatever stored procedure or function. Again, you can use this question marks as, you know, your parameters. You prepare a call, then you register. Here's an interesting one. Which one of these question mark, if any, is an output parameter? So for example, this could be what your function returns, right? So you're saying, oh, okay, well, the first question mark, suppose that's your output parameter. And then you say, what type should I expect? When I call that stored procedure, should return me varchar, yeah? Fine. And then you set up values for input parameters. You can use the style of set object, parameter index, parameter value, parameter type, or you can use the style of set specific type version method, yes, set date, whatever, position and value. Yeah, it's up to you, whichever way you want to do it. Okay, so you could set values, you can register output parameters, then you execute the code, yeah, execute that call, and then you get whatever you described as an output parameter, you get it back. Again, you can say, get me object on a given position, expect certain type, or you can just say, get me string, for example, yeah, and then qualify the position. And so that's how you execute callable statements. Now, let's assume that your statement is a query. So you're executing a statement, it happens to be a select statement. So you're doing this execute query, all right, and you get a result set. You get a result set. So you set up your parameters, you execute the query, you get results set. Fine. Then you can step through the result set using method next, which does two things. It checks if the next record actually exists. Because you may have a situation where query return no records at all, or you may have a situation where query returns certain number of records, but then sooner or later you run to the end of the result, right? So how do you know you don't have any more records? Well, the next method will return you false if that's the case. What else the next method does? It actually fetches the next record. It moves a marker to the next record. So within that while loop, in every iteration, so long as the method next returns you true, the marker will be moving from one record to another, to another, to another, right? That's the logic. So you're doing this next method call, and then you can retrieve values from your record, yeah? There are, again, several ways in which you can do it. You can do the get object, which implies that you need to specify position and type, or name of the attribute from a query and type. It works either way you want. So you can use positions or names. Or if you don't want to use get object method, you can say use get int or get string. But again, you specify the position or the name of the column you're trying to retrieve. Yeah, so column names here are ID name. Yeah. Position starts from 1, not from 0, just like parameters. Yeah. Please note that. Okay, so that is a forward-only style of behavior, right? That's a default behavior. There are apparently other options, yeah, but by default, the query will be processed in this forward-only style. So that's kind of it. That's how you form statements, and that's how you process the results, right? Now, at this stage, I would like to highlight the reason why basic statement is something that you're advised not to use, and you're advised to actually use prepared statement instead. Yeah. So if we go back a couple of pages and we'll look at the difference between prepared statement and a basic statement, we notice the prepared statement uses these question marks, right? Substitution parameters. And a basic statement doesn't, it uses concatenations. So with a basic statement, you have to concatenate values in before you execute the query. You don't have a phase of actually setting parameters. So that basically means that a query is recreated physically, as the entire string is recreated, reparsed, and recompiled every time you specify different parameters and you proceed to the execution. With the callable or prepared statements, that's not the case. You prepare the statement first. It's parsed, compiled, and validated before you even set any parameter values at all. So by the time you set these parameters are treated as pure values. They are not treated as part of a statement as such, which means that you're preventing code injections. There is a problem called SQL injection. What if the text concatenation that contains the parameter value, as you use in a basic statement, what if that value of the parameter actually contains the next SQL statement? What if the user, instead of typing somebody's, product price or something, what if they type the entire SQL statement there? Then because it will be concatenated into the string, parsed and compiled, it will appear that you'll just execute an injected statement. So that's the security hole of a massive proportions. The substitution parameters used by prepared or callable statements avoid the problem, because the statement is precompiled beforehand and a value will not be treated as another SQL statement. So there you go, right? It actually is safer. And mind you, the prepared statement or callable statement is compiled earlier, yeah? And you only specify parameter values later. So again, there's a performance advantage here. All right. So we approach the part of this presentation where we have some understanding of how we connect, how we create statements, and how we actually execute them, right? How we process query results, for example. What about transactions? What if you want to actually control transactions? Well, you find out the JDBC driver by default is in the auto commit mode. Every time you execute the statement, your JDBC connection automatically commits. Well, you may wish to change that behavior. And to change that behavior, all you need to do is set auto commit false. Tell the connection don't commit automatically. Fine. In which case you may decide, oh, I want to place some save point and I can actually roll back to save points, or I just want to commit the transaction, or just want to roll back the transaction. You control it now. It does not automatically try to commit after every statement execution, right? By default, it does. So I suppose if you have a problem like an exception or something, then you can roll back, yeah? Okay. This is a really important point. If you perform normal connection closure, if you just do connection close, like in finally block, for example, even if you turn auto commit off, if you did not explicitly roll back, if you just proceeded to close in the connection, the database will assume you want to commit, because you didn't end up with terminated connection with exception. You ended up with correctly closed connection. So the environment around your program has no reason to suspect something is wrong. The database will think, oh, well, everything is fine and the commit will happen. So probably you want to be mindful about it. And when you come to the point when you close the connection, just make sure you know what you want to do. You can explicitly commit or you can explicitly roll back depending on circumstances. kind of don't leave it to chance. That's what I'm trying to say, I suppose. When you connect to the database, you may wish to discover what your database is capable of. Because so far, except one place in a program, which is the JDBC URL itself, which is really just a string, nowhere else did you really write any code that's database specific. Yet you can write code that's database specific. What if I want to write some SQL statement that only works in, say, Oracle database or only works in MS SQL database? Yeah. So yeah, sure, why not? You may wish to do that. But in order to do that, you have to first check where are you connected to, which database, what it's capable of. So you wouldn't do something that a database does not support. So for that, connection object gives you the method getMetadata, which returns your database metadata object, which has dozens of methods, lots and lots of methods that tell you what the database supports, what a database is capable of. Here's a small subset of these methods, just some examples, like what's the database name and version, what are supported SQL keywords, does this database support outer joins, does it support save points, etc., etc. So lots and lots of methods. You can dynamically interrogate your database and find out what it can do and how does it actually work. Likewise, you've got an ability to interrogate the result set object. When you run an SQL statement as a query, you've already noticed that you can form these queries dynamically because they're just strings, right? So you can dynamically form an SQL statement. Prepare it, then, substitute parameters and off you go. But the question is, if you dynamically form an SQL statement, then how do you know how many columns you've got? What are the column names? What are the column types? Well, there you go. Metadata. Result set metadata object. You could find out column counter for every column. You can find out its name, its type. So now you can write code that will dynamically adapt to the structure and nature of your query, right? Even if you form the SQL statement on fly. Okay, now remember we were talking about a result set, and we said that by default result set traversal direction is forward only, right? We mentioned that. Well, apparently you can change it. You can make it not just forward only, and there's some other things you can change in the behavior of result set. So it is result set type, which determines the result set traversal order. And also there's one more thing the result set type does. It will determine the way in which the changes in the underlying database are reflected in the result set. Let me put it this way. Imagine you run a query on a table. So you execute a select statement, you get your records back. And whilst that is happening, in the database, some other transaction just modified a record and committed it. So another transaction made some changes and committed these changes. Question. Should you see that record? Should you see the change? Or should you see the state of the record as it was at the beginning of your query, rather than the state of the record that emerged after your query already started? Now, we're not talking about looking at uncommitted changes. No. We're looking at changes that were committed by the transactions. Still, the question remains, which state of that record set would you like to observe? And different databases can work out that question differently. It depends on the database type, but it also depends on what type of result set behavior would you like to qualify. So you have some control over it. Then there is another question, which is result set concurrency. Do you want to be able to update records in that result set? Yeah, updatability of these records. So to be decided. And finally, result set holdability. If I get the result set, if I get records, and then I do some actions, and then I commit, does the commit automatically causes the result set to close or not? Again, it depends on the database. Some databases can do retention of result set over commit. Other databases can't. They can't retain it. But again, if the database can retain it, do you want to enable that? Don't you want to enable that? So you can play around with that. This is something you can set on statement level for prepared or generic statement. Yeah, so these are the parameters you can set. Following pages explain these options in a little bit more detail. So let's take a look. This is result set type. Yeah, result set type by default is forward only. So that basically means that the only method that will work is the method next. Also, the reflection of changes in the aligned data source will be database specific. So if another transaction changes records and commits them whilst you're going through the set of records, whenever you'd see these records changed, or you'd see records as they were at the beginning of your query, will depend upon which database you are connected to. Right? So some databases can do it one way, other databases can do it another way. If you set the result set type to be scroll insensitive or scroll sensitive, then you enable, in addition to method next, other methods such as previous, next, first, last, absolute, and relative. So you'll be able to go forward and backward in that result set and navigate around rows. Insensitive option will basically ask the result set to present you the data set without reflecting changes that were occurring in the underlying database. And scroll sensitive version will ask you to present result set which does reflect changes that occurred in the underlying database. To find out if your database actually supports these options, you should call database metadata supports result set type method, because then it will tell you what the database does. Yeah, you would know if it supports these regimes. The default option works with any database, but then these other options, well, that depends. Yeah, so you can check the result set type support for that database. Result set concurrency, that's pretty straightforward. It could be concurrent read-only or concurrent updatable. If it's concurrent read-only, which is default, then you just get records, you're not supposed to update them. If it's concurrent updatable, then you get the result set objects and you can actually change them, right? So that's the idea. Result set holdability. That controls the retention of a cursor or closure of a cursor across the commit. So if you're committing, is your result set stays open or not? So possible values hold cursors over commit or close cursors at commit. The default behavior is database dependent. It depends. Some databases may by default hold cursors over commit. Some databases may close cursors by default upon commit. How do you know what your database is doing? Ask database metadata object, it will tell you. Yeah, okay. So you could find that out by requesting that information from the metadata, and it will tell you what the database will support. These are fairly advanced sort of tuning topics, right? But then again, they're practical because I guess quite often you would want to write code in the JDBC that exploits database specific features for performance reasons, tuning reasons. And yes, otherwise JDBC code is kind of portable across any database in the world. Then you wouldn't take, if you would not consider these features, then you won't be able to take advantage of performance or enhancements that a particular database would provide. Yeah, and code will work across databases, but it will work in kind of a vanilla way. Yeah, whilst these options allow you to customize it a little bit more. All right, well, that's the end of this presentation where we've observed what the JDBC protocol generally does. Yeah, how it can manage different database connections, execute different SQL statements, process query results, manage transactions, discover metadata, and we know why it's important now, and also customize the query result processing. That's pretty much it. And I guess from here onwards, the things to look forward to is to study further automations on top of the JDBC, such as JPA. Yeah, which we've mentioned earlier in this lesson.